Hello. Yeah, so today I will discuss about the random forest algorithm, and I will try to implement that model, and we'll go through all the process from dividing that data set into training data set and testing data set, and then fitting the model, random forest model, on the training data set, then predicting for the test data set, discuss about the random forest parameters like entry and node size and all those things, how to fine-tune the parameters, what is OOB, out of bag rate, misclassification rate, how to plot the importance of each variables, how to find the importance of each variable in predicting the test data set, how to plot AUC, and how to get the AUC and plot the ROC curve, and so on. So let's begin by importing these two libraries, library mass and library random forest. Just type in library mass, library random forest, and control enter. Set the seed so that each time we run the random forest we get the same predictions. So set the seed 1 2 3, anything you can put in here in 1 2 3 1 2 3 4 5 or 4 6 1, anything. So now store the data set, not the burst and data set, but birth WT. This is the name of the small b. This is the name of the data set, and this data set is available in the mass package as we have imported it. Now just data frame but the WT. Let's have a look on the data frame. The number of rows is 189 and 10 columns are there. Let's have a look. The variables are low, age, LWT, race, smoke, and these things. So we can know that what are these variables just by taking the help on this data set. Seems like some values are numeric and some may be categorical, because as you can see in race we are having unique values, only 2, 3, 1 and so on, and in the smoke we have either a person is smoking or not smoking, so 0 for non-smokers and 1 for smokers, I think. So, and like similarly low, I think these are 0 and 1 values which we want to predict. So this is the target variable, low is the target variable which we want to predict, and these are the predictor variables from age to PWT. So we can see that some are categorical, like race, smoke, PTL, HT. Seems like these are categorical because there are only 2 values, 2 or 3 values. We will have a look on that. So let's have a closer look on the data set. Health, birth, WT. On the right hand side you check the risk factors associated with low infant birth rate. So it is telling about the data frame. What does low means? Indicator of birth rate less than 2.5 kg. So if the birth weight is less than 2.5 kg, then it is saying low, which is the binary predictor, that is 1, and if it is not less than 2.5 kg it will be 0. Then age, that is the mother's age in years. LWT, mother's weight in pounds. Race is mother's race, that is white, black or other. Smoking status, whether the lady is smoking during the pregnancy or not. PTL, number of previous premature labors. And HT, history of hypertension. So these are the history, these are the data related to the mother, and we want to predict the birth weight, if the birth weight of the child is less than 2.5 kg or not. So obviously it will depends on the number of factors which are related to the mother's age, weight, race, smoking. So for an example, say So maybe as smoking is a bad factor, and maybe the birth weight is less than 2.5 kg for those women who are smoking. But this is just our intuition. So let's have a look and fit the random forest model and see that which of these factors are responsible for the low weight. So low is a binary variable, and we will be predicting these predicting the low variable using these predictor variables. So number of variables are 10. So one is target, that is low, and the other 9 are predictor variables. Let's have a look on the data frame. It's str data frame. See, it's similar to like looking from here on the right hand side. Just click here and see the values. Now let's have a look on dimension. That will give the number of rows and number of columns. Let's have a look on first 3 rows. You can see like this: head, data frame, comma 3. Summary, you can check it like this of each of the variables, like low. Summary is min value, max value, first quartile, third quartile, mean and median values. For each of the variables you can have this statistics. So you can have a look on what is the min value, minimum value, and what is the maximum value, and you can also plot the histogram or bar plot to know the number of unique values. But just a shortcut to find the number of unique values, you can use this apply function, data frame 2 for columns, and then write this anonymous function. You get this. You see that number of unique values in 2 is low. In low is 2. That means it is a binary variable. It's whether the weight is less than 2.5 or not. So it is 0 or 1. Age is obviously a continuous variable. That's why it has many unique values, 24 unique values. There are 189 observations, in which 24 are unique values for the age. If you want to check it out, how does this age looks like, you can check the histogram. Hist data frame $age, like this. So you can see that the age is distributed between 10 to 45, and most of the ladies who are having pregnancy is around 20 to 25. So this data is telling about that. So you can see the race are 3. It's a categorical variable, whether it is Asian or other and whatever. Then smoke, whether the lady is smoking or not. So it is binary again, PTL, HT, UI, FTV. All these are categorical variables. So we need to convert them. Yeah, so we need to convert them into the categorical as dot factor, using as dot factor, because if we don't convert them, then they will be treated as numerical data, and then random forest will treat differently. And so since they are categorical variables, we should convert them into factor form using the as dot factor. And random forest actually have a split on the factor, having n levels, and then it makes a selection of one of the 2 to the power n minus 2 raised to n minus 2 possible combinations of all those n levels. So if you just use normal numeric values of the variable, then that will be treated differently, and the random forest will then sort that numerical values of the variable and then split to minimize the Gini impurity or entropy. So categorical variable and numerical data is actually treated differently. So you should always first check it out that whether any variable is it's a categorical or a numerical. Even though the data here is already shown in all the numerical values, but still it is not numerical data. So race, smoke is obviously not a numerical data because it is 0 and 1, and it is telling that whether the lady is smoking or not. So you should convert all these into the factor variables, these all 6 variables into factor, so that random forest knows that these are categorical variables, and then make a split according to that instead of treating them as numerical data. So let's have calls all these categorical data, columns are stored in calls, convert them using the for loop into factor data, then again check the data frame. Now you can see that we have converted these rays, smoke, PTL, HT, UI, FTB into the factor variable. The rays has 3 unique values, smoke has 2 unique values, PTL has 4, HT2, UI2, FTB 6. So these are categorical data and these are numerical data. Age, LWT and BWT, these are numerical data. So for random forest will treat differently these categorical and numerical, and low is the target variable, obviously a categorical data which we want to classify. Let's now divide the data set into training and test data set. So library CA tools has a built-in function which has sample.split. Then just split this data frame $low, split the variable low, which is the target variable, split ratio 0.7. that means the train data frame has 70% of the rows and test data has 30% of rows. So you can see here train data frame 132 observation goes to the train data and 57 observation goes to the test data. Now you must have read before that what is a decision tree, and you must know before reading random forest you should go through some basics of decision tree classifier, but I will explain a little bit about decision tree classifier. So in decision tree classifier we make a split on each of the variable in order to predict the target variable, and again it also treats random factor variable, categorical data and numerical data differently. For numerical data it sorts the values, and for categorical data it finds the best combination of the levels and then split accordingly. So if we have a good decision tree, and if we are saying high strength of tree, that means its error rate is very less, means classification error rate is very less, it is not predicting wrong if it is having high strength. So single decision tree with high strength means its accuracy is high strength, high accuracy, or low error rate, same. So now let's go on random forest parameters. So first is mtry, that is number of variables selected at each split. So what is random forest? A random forest is like a forest of decision trees. So earlier when you are fitting a decision tree alone, you are fitting one tree where you are taking all the variables and making the best split on each variable and then finding predicting the target variable. But in the random forest what you do is you select, like you go to the data frame, you have 9 variables, predictor variables. So you at a time you choose say 3 variables, so that will be mtry, and then at a time you choose say 50 rows for the fitting the model. So mtry will be 3, and if we are choosing 50 rows at a time, then that will be sample size. So for each tree, when you fit a model, you are taking mtry is equal to, if you are taking mtry is equal to 3, that means at random you will choose 3 variable out of these 9 variables and then take 50 rows and fit a decision tree. So mtry say 3 and sample size is say 50. So now the regression. For regression, if you are doing the regression in the random forest, you can take the default value of mtry is number of variables divided by 3. So number of variables here is 9 predictor variables, so 9 by 3, that means 3. So mtry default value will be 3 for regression, and for categorical you take the square root of number of independent variables. The square root of 9 will be again 3, so mtry will be again 3. So floor function is actually just converting the decimal values into the nearest integer. So here you are having 9 variables, so mtry will be 3. You can choose 4, 5, 6 and try to find the best value for the random forest. So what does lower mtry means? That means if you are having less number of variables chosen at a time, and say you are choosing 1000 trees to be built, so each time you build a decision tree, you take 3 variables, you take 50 rows and fit the model. Second time again you take any of the 3 variables, take any of the 50 rows randomly, fit the model. You do it like 1000 times, and then you predict for the test data. Each of the decision tree will give its own answer or predictions, say 0 or 1. So each of the decision will give its own vote. Then if we are fitting 1000 trees, then 1000 trees will have its own opinion, so that we will take the average of all those opinions, and that average is actually the answer given by the random forest. That is the prediction done by the random forest. So if you are having lower mtry, that means less correlation between each of the 1000 decision trees, because each of the decision tree will take different variables. If you choose mtry is equal to the number of predictor variables, say 9, then and you are fitting 1000 decision trees, then each decision tree is taking the same variables, all the 9 variables. So there is no difference in the decision tree. In order to have variety in the decision tree, you should choose mtry lower than the number of predictor variables. That you have to optimize. And sample size should also be lesser than the number of rows. Why? Because if you are taking the whole data set for each decision tree, then decision tree is not learning anything new if you just talk in terms of number of rows. So the lower mtry will mean less correlation between the individual decision trees. As I already told, if you are taking few variables, then each decision tree is taking different variables, different set of variables, so it will have different training and they will learn different part of the data, but it will decrease the strength of each tree. That means the individual decision tree will not be will not be having good strength. That means that will not be able to predict accurately. Why? Because it is not taking all the variables into account. It is not learning the whole data. It's just taking few variables, which is depending on an mtry. Say mtry is 3, then it is only taking any 3. Each of the tree is only taking any 3 variables. So the strength of each of the individual tree will be very less. So that is not good. That is a bad thing. But less correlation between trees is a good thing, because there will be variety in our 1000 decision trees. So we need to optimize between these two things, good thing and a bad thing, and this depends on the mtry. So you need to optimize the mtry. Node size is the minimum size of terminal nodes. So if you have the larger value, then the smaller trees will be built. That means the lesser number of splits will be done on each of the individual decision tree. Now let's fit the model using the function random forest. So random forest and then low tilde dot means the rest of the all of the rest variables are being used as predictor variables. Data is 3 in data frame. mtry we are choosing as 3 here, a square root of the number of variables, that is square root 9, and say that we are fitting 20 decision trees. Let's check out what does this model has. Write model and random and control enter. You see that what is showing, this is the formula. What is it showing? What we have written here. Then it is showing the number of trees which we have put here, 20. Number of variables tried at each split, that is 3. That is the mtry which we have put here. Then OOB, estimate of error rate, is 0. That is very good. So lesser OOB is good. Why? Because OOB means out of bag rate, that is the misclassification rate, or in this so each decision tree is tested on 1/3 of the number of observations, which is not used in building the decision tree. So each time we are fitting a decision tree, we are taking a few sample size, and sample size is around 2/3 of the number of observations, that is the default value, and then we are estimating the misclassification rate for all the decision trees on the left 1/3 part for each of the decision tree. So take one decision, take for each decision tree, take any number of any 3 variables, take 2/3 of this number of rows, like 2/3 of 189, random sample, and then fit the model, decision tree model, do it 1000 times, and that is the random forest. So now let's high strength of tree will have low error, depends on mtry. That means if we have a good strength of each of the individual decision tree, that means we will have the good forest, random forest, that will have lower error rate, or you can say it will random forest will predict accurately, because each of the decision tree is having good accuracy. High accuracy between the decision trees increases the error. Why? Because each of the decision tree is not learning anything new, they are almost the same copy of each other, because and this could be because of mtry is almost equal to the number of predictor variables. This could be one case. Now let's check out that out of these 9 variables, which are the important ones in the random forest. So when we are splitting in any decision tree, we are using the Gini index or entropy to make a split. What is Gini and entropy, that I will explain in later videos, or maybe in the decision tree video. So let's check out what is the importance. So here you can see the mean decrease Gini, and then you can just use the function var imp plot, then the model name. This model name, you can see here on the right hand side that BWT is on the right hand side, that is having value 45. That means if you remove this BWT from the model, then the decrease in the Gini index will be around 45. So higher the mean decrease Gini for any variable, better is the variable for the prediction. So BWT is the most important variable for prediction for this model, as it's have high mean decrease Gini, and rest of them are almost the same. So this is the most important, then this, and then this, and then this, you can see. So this is having the highest mean decrease Gini. Let's do the predictions. For predictions we use the function predict, and then model name, model random, then the data frame, test data frame, and then type class. So we will get the predictions for the classes. So let's see what is in this. So we get the either 1 or 0 binary prediction. Let's check out the table. So we can see that actual values, so there are 38 actual values for 0, and predicted ones are also 38, and they are accurately predicted. Actual for 1 is 18 and predicted for 1 is 18. So 18 are actual and prediction are equal. For 18 observations, predictions and actual are equal, are same. So diagonal ones are high, that means it is having high accuracy. You can check by this code, sum diag t is the table which you have here, sum of t. You see it is having accuracy of 98.24 on the test data frames. That's quite good. So for this data frame, it is random forest is learning quite good. Let's check out this accuracy. This was the accuracy metric. We can also check the AUC metric. We have to use the library PROC. If you don't have, you can just do like install packages and then you do PROC if you don't have this package, and then do the prediction with probabilities. So you will have the probabilities for each of the classes. So we have two classes, 0 and 1. So for 0 we have the probabilities, and 1 we have the probabilities. So these are the probabilities. So this tells that 80% probability, this observation has 80% probability of being in the first class. This one, fourth one, it index 88, this one has 90% probability of being in the 0 class and 10% probability being in the class 1. These are the probabilities. So for probabilities you have to write type prob. Earlier we just used class to get the we were not interested in the probabilities. Now we are interested in probability for finding the AUC. For finding the AUC you have to use the function AUC, use the actual values where test TF dollar low, these are the actual values, and then type in the predicted values. This is prediction with props, and we are taking the second row, that means this one. Then you get the AUC of 1. So that's quite nice. So means AUC is actually telling about that that model is quite good in differentiating between the two classes. So yeah, so you can also plot the ROC curve here by using this function ROC, actual values, then prediction, probabilities, like this. That's quite good. So you can see the AUC is, it's quite a rectangle shape, and its AUC is 1. Now let's find the best M-try. So for finding the best M-try you can use the function tuneRF, then the train data frame, then the target variable, then end tree try means number of trees you want to fit in, step factor, that is 1.5. that means you want to make a step on M-try. This M-try will decrease by 1.5 on each iteration, and if there is an improve in the model by 0.01, then it will go ahead, else it will stop. So let me just check it out. Just a moment. Yeah, so you can see that if you fit if you are putting all these values, if I have just changed the values, so number of trees I have taken 200 and step factor is 1.2, you're taking in on each iteration, you're changing the mtry value is by 1.2, and the number of trees which you are fitting is 200, and if there is an improvement in by 0.01, then only the algorithm will move ahead. So we just do it again. We see that the best mtry is 3, for which the OOB, that is misclassification rate, is 0. That was the default value, and in this case we are getting the same value, but maybe depending on your data you will be having different m values, and maybe it is not the same as the default value. So you can use the tunerf model function for finding the best value of mtry. Now depending on your data, you may need to do the imputation for the missing values, and maybe you have to clean the data, finding the outlier observations, because these are very important for fitting the model, any kind of model, maybe it is a random forest or any model. So that I will make a video on that. So just a short come of random forest, I will need to tell that if there are certain categorical variables which has many levels, then random forest is biased towards using those variables more in trees. So if you choose the mtry, say 3, and you have some of the variables, say like here, some of the variable is having more unique values, maybe some has 6 unique values, maybe some have 2 unique values, like smoke has 2 only, and some of them have many unique values. So then random forest try to choose those variable more, like say if ftv has 6, if it has, say for example, it has 6 unique values, and random forest will always try to choose this variable in each of the sample fitting. So this is just one of the drawback in this algorithm, random forest algorithm. There are also many different versions of this algorithm you can have, but this is just the basics of random forest, how to fit this model in R. So if you have any types of question, you can comment on this video, and please do subscribe, and thank you for watching.